This is Algebra 1, Term 2, Lesson 3. We'll be looking at coins and cars, both linear functions and different ways to look at them. Cars is not really a sequence activity, so if you had to cut back, you could drop that one. Then brick wall, which is a really fun polypad activity, and then the story of Fibonacci. So let's start with the coins problem. The first thing kids will do is they will open polypad and they will build out the fourth and fifth day in this pattern. They will create a function, identify a rate of change, y-intercept, and insert a screenshot. So let's take a look at the polypad. So when they get into polypad, they will see a pattern, a coin pattern like this. They can close this box over here by clicking twice up here to give themselves room. Here is the pan tool so they can move this around. But the goal is for them to create day 4 and day 5. And I do give them instructions in the slides to click on a coin. So let me click the move tool and then click the coin, and then here's the copy. So they can copy a coin and build the other two. And then they're to write an equation for a function to represent. Now there is a tool in here to write equations. It's down in the bottom, so you can direct them there. Or students may prefer to use the Desmos calculator, or they may prefer to use math.new, which is the graspable math tool. So any of those are fine. I believe I did use the Desmos calculator in the teacher notes, so you'll see that, but however they want to build it. So once they've built all of this, they will take a picture and drop that onto their slides. And then they will answer these questions. What is the rate of change, and where do you see that in the coin pattern? What is the y-intercept? Can you see that in the coin pattern? And then of course they need the screenshot. I do have some guiding questions in the student notes section. So the next activity we're going to do, this one should be fairly quick. I'd say 10 or 15 minutes probably for most students. This is car races from GeoGebra, and students will compare rates of change for different cars using 5 different representations. They have to get 5 questions correct on the first try, and then they'll take a screenshot and insert their work on this slide. Now this particular activity, they've changed it. I didn't have this before, but if they get this screen, they'll need to click on Student Preview, and then they'll go in to do the task directly. So this is the screen I normally get. As soon as they pick a car, it's going to tell them check 3. That means they can do this up to 3 times. And then they're going to click check. Now let's make sure that's the right one. Maybe it's not. Let's click on it. It'll say no. If it's correct, it's actually going to show the cars racing and show which one was first, second, third, fourth. And then they're going to have to do it again until they get this to say 5. So once they've done their activity, they're going to take a screen capture. We make sure it says 5 down here. So that's the correct one. Okay, and then they'll click this purple button to get a new problem. So the goal is to get 5 correct on the first try. And you notice I didn't get it on the first try, so I got nothing. They got to get 5 correct on the first try. Okay, the next activity, I would actually do this in 2 parts. First, they will go to polypad and they will build different ways of getting a block pattern. So let me show you what that means. So another polypad activity. This time it's actually a full activity. Again, they can click here to close this. They can pan, they can expand. So I mean, they can go in like this if they want to see it better. They can move it over. So let's go back here. They're looking for the number of ways to build a wall of 1. And there's really only one way to build a wall of length 1, and that's with a vertical tile, because their height of the brick is 1 unit. And then if you want to do it, there's 2 different ways to build a length of 2, and so on. So they're going to build out the 4 and the 5. They are not asked to build out the 6, and they're not asked to build out the 10. And as they get the number of ways, they type the number in this box. So since there's a 1 here, when they type 1 and click off, it's going to turn green and have the little celebration to let them know they got it. And they're going to continue down that way, building them out and answering it. The thing is, the numbers get kind of big, as you will see. So my guess is I would probably stop it when most of them have finished building out 4, maybe 5, maybe halfway through 5. I would just pause the class and go, "Okay, class, we're going to go work on a Desmos activity." And the reason I say that is this is going to get them the Fibonacci sequence. They have not been exposed to that yet. If you want to go all the way to the end with this and let's see if they can get it first, that's great. If you have time, do it that way. That's probably best. But the goal here is to have them come back to this after they've done their Desmos activity and finish it, because it does take a little while to build the 5th one. And let me show you something that if you don't know, you can do in here. What you can do is you can highlight like that, and then you can copy. So you can basically copy one you've already made and add and move it around, add tiles. So that works too. See, I can move this around like this too. So I can highlight a whole thing and move it around and then click off, and then it's now separate tiles that I can move around. So that's something to consider. But have them build this out. It does take time for some kids. Some will come up with lots of shortcuts and do it quickly, but some take a while. So prepare to spend time here. Now this activity is rather lengthy if you go to the actual site that I gave you. So in the teacher materials, there's a link out to the official site for this problem, and let me show you that. And this is the full lesson plan at Amplify for this activity, and it goes through this part, which is the beginning. But here's extensions. So here's where if you want to take a whole nother day on this, you could go on with these extensions and look at this other ways. This gets into Pascal's triangle and other combinations. There's also a Desmos classroom link to a different activity as well. So feel free to explore this. This is in your teacher guide, but it's, what I would do is probably for this lesson, I was only planning to teach this one day, so I would probably just stick to that original polypad and just let that be the end of it. Fibonacci is not a huge part of the Algebra 1 curriculum. In fact, most students or most schools don't include it, but I wanted to include something other than just arithmetic and geometric, because there are other types of sequences, and this is a famous one that a lot of people know about, so why not? So let's look at the last activity. This is the Desmos activity, and it's about Fibonacci. So this activity is really more of a history lesson than a math lesson, as you will see. There is a little bit of mathematics in here with the actual Fibonacci sequence and how he actually made it famous by using one math problem. But this goes through the history of how Fibonacci, this person, brought the Fibonacci sequence to the Europeans. Now, these questions all have just one answer, and they're silly, and they've just got pictures. So this is not intended to be anything they need to know. They just need to click. And I tell my students as they do this little story, basically, as long as you're clicking on everything and reading it and looking at the pictures, you're doing what you're supposed to do. So there are 22 slides, but there's literally no work on the majority of them. So as long as they click here, then it's going to open up some silly picture, and they'll be done with that. So here's, see, one answer. So it's multiple choice, but the one answer, they just click on it. Now this one is one of the few that has 2 answers, but both are correct, so either will work. And they can change their mind if they want to see what both of these reveal. But each of these answer choices are going to reveal fun little pictures. And then you're finally going to get over here to the fun part, and that is your Fibonacci sequence. So this kind of is the actual problem that was used by Fibonacci to kind of show this particular sequence in. And on this one I had them draw, so when they get to this page, it doesn't have anything past this one. There's 3. They could draw a dot pattern to represent the same thing, or they could, I mean, heck, if they can draw bunnies, go for it. That'd be hard for me, but I'm asking them to continue the pattern. What would be the next one? 1, 1, 2, 3. What's the next number of adults? And then here, what's going to be the next number? Now, we're continuing the Fibonacci sequence, and this is why I said do this first, because now they can go back to their brick pattern and see if this is helpful. And then it goes on to talk about the Fibonacci sequence and some of the things that we see in nature and how this appears in other places. But anyway, it's just a history lesson. It's supposed to be fun, and hopefully they learn a little bit about some of the mathematics in our history. Is not, we attribute things to people that didn't necessarily do it. It's interesting, I just listened to a history podcast about Thomas Edison, and everybody thinks he invented the light bulb, but he didn't really invent the light bulb. There were a lot of people that did that before he got to it, but he did do some things to get us all a light bulb. So he contributed, but we sometimes give the wrong people credit just because they're popular or famous. And I think that may be true about Fibonacci. But anyway, take a look at that. That's quite interesting. And that is all I have for lesson number 3. We're going to move on from sequences into other topics. Y'all have a great day.